Hello everyone. The goal of this video is to show and to draw the shear force diagram and the bending moment diagram using the relation between the distributed load, the shear force, and the bending moment diagram and the bending moment, rather than to do a section method, which will take you a lot of time, much more time than the next method. So what we have here is a simply supported beam with two cantilevers. At point B we have a support, the hinge support, with two reactions at and at point D we also have support, only vertical one. So first what we need to do is to calculate the reactions. Of course, if we will do some of the forces in x direction, we will find that the reaction in horizontal direction is equal to 0. And what we need to do now is to find the vertical reactions. So to find, let's say, the vertical reaction at point B, we can do some of the moments at D. So if we're doing some of the moments at D, we will find that the reaction at B equals to 7 kilonewtons. Some of the forces in y direction, we can find the reaction at D also, and it's equals to 4 kilonewtons. Great. So now we have all the reactions. Next step, always above the shear diagram, always you must show the free body diagram of the beam. Let's see. So let's replace the support by the force that's acting in point B, 7 kilonewton. And the force at point D, 4 kilonewtons. Great. Now we have the free body diagram above the shear diagram. We can start our solution. So at point A, we don't have any concentrated loads, so we have no jump. We're starting from a value of 0. And we know that from point A to point B, the change in the shear force is the area here. So it's 6 times 0.6. So the change from point A to point B will be 3.6, and the force is acting down. So this value is negative 3.6 kilonewtons. Great. At point B, we have concentrated load of 7 kilonewtons. Concentrated load of 7 kilonewtons, it means that we have a jump of 7 kilonewtons, and the direction is up. 3.6 means that we will have 3.4 positive. Great. Next step. From point B to point C, we have no forces. It means that the shear diagram, the shear force stay constant. 3.4. At point C, we have a jump of 2 kilonewtons down. 1.4 at point C. Then from point C to point D, the change in the shear force, we're starting from a value of 1.4, but we need to decrease this value by 1.2 times the value of the uniform distributed load, 3. So it means 3.6. So we're starting from 1.2, we will finish with minus 2.2. And uniform distributed load, one more time, the shear force will be, the shear function will be linear. Great. If it's not clear, I always will write here L, if it's linear. Next. So somewhere here we have a shear force which is equal to 0. Let's go to this distance, any x that we will find next. Okay, let's continue. From point D we have concentrated load. It means that we have a jump of 4 kilonewton up minus 2.2, it means that here we will have 1.8. Then from this point, we're going down 0.6 times 3, 1.8. So we're finishing with 0 shear value, as we can expect. Maybe it's important to mention that we have here the same slope as we have same distributed load value. Great, so this is the shear diagram. Next step is doing the moment diagram. I just want to remember you guys that the relation between the shear and the moment, the change in the moment diagram, equal to the area of the shear diagram. The slope of the moment diagram equal to the value of the shear force. Great, so if it's uniform, constant function, linear function, it means that we will have here parabolic function. So we're starting with 0 moment. We know that at the ends, if we don't have a fixed support or any concentrated moment, we will start from 0. So it means that at point A it's going to be 0, and also we can say that at point E it will be 0. Even if somehow you're getting at the end a value which is different than 0, still show a value of 0 because it will show that you understand the material. Great. So starting from A, starting from value 0, and we know that the change in moment from 0 to this point B is going to be the area of this triangle. 3.6, it's the height, the base is 0.6, so it's half 0.6 times 3.6. We will have a value, let's write it here, half 0.6 times 3.6, the value of the moment at this point, minus 108. So this is minus 108. Now we know this is a parabolic function, but we don't know if to show it like in this kind of slope or this kind of slope. How can we decide it? We know that the slope of the moment diagram is the shear value. So we're starting from shear equal to 0, so we know that the slope at this point is equal to 0. So it means that this is the right solution. So the moment diagram will look like this. Okay? We can write here even slope 0 at this point. Great. Now we're going to continue. Going from this point where it's 1.08, and we want to go to point C. So we need to add this area. So we're starting from minus 108, and we want to add the rectangular area. So it's going to be 0.3 times 3.4. We'll get minus 0.06. So this is the value here. 0.06. Constant function, and it's a constant shear function. It means that we will have linear moment. I'm showing it like this, and I always will write here, if this was parabolic one, I will write here P. This is linear. I'm writing here L. Great, next one. Next value that we want to represent is the value where the shear equal to 0. As we said, the slope of the moment is the shear. If the shear equal to 0, it means that the slope of the moment is 0. It means that it's maximum point or minimum point. In this case, of course, it's a maximum point. Let's show it like this. And we want to find what is this value. So we're starting from 0.06. and we need to add the area of this triangle, small one. But before, we need to find what is x. It's easy to find what is x because we know this value is 1.4, this value is 2.2. We need to find this x, but we also know that the length of the total length here is 1.2. Means that this one is going to be 1.2 minus x. So similar triangles, 1.4 over x equals to 2.2 over this length. So 1.4 over x is equal to 2.2 over 1.2 minus x. From here we can find that x is equal to 0.467 meters. Great, so now we can find the area to find the moment value. So it's going to be 1.4 times x over 2. And it's positive because the shear value is positive. So half 1.4 times x, 0.467. The answer is 0.267. Great. Next value that we want to find, the moment at point D. Now we need to take this area, but because the shear is negative, we're going to take it as a negative value. So we want to find what is the moment here. And of course it's linear, it means that it's going to be parabolic. Let's say something like this, and we want to find this moment. So it's going to be 0.267, let's write it here. 0.267 minus the area under the triangle, the area of the triangle. It's going to be 1.2 minus x, so it's triangle, half 1.2 minus x, which x we know, and times 2.2. This is minus 0.539. And the last thing that we want to do is minus 0.539 plus, because it's positive shear, the area of the triangle. So it's going to be 1.8 times 0.6 and over 2. It will give us exactly this value of 0.54, and we're going exactly to 0. Of course, when we have a difference of 0.001, we can say that this is exactly 0. Linear function, it means that we will have here parabolic function. Shear equal to 0, it means the slope here is 0. So it will look like this. Now we will show that where we have parabolic and when we have linear functions. Because all this is linear, are these linear functions. And all the functions here are parabolic. So this is very efficient way to answer this kind of questions of shear force diagram and moment diagrams. Very important to show the free body diagram above. In this case, we will see exactly if we have a concentrated load, we expect to see a jump here. If we have a concentrated moment, in this case we don't have, we expect to see a jump in the moment diagram. So this is the way to answer these questions. Always we can check ourselves to see that we finish with 0 values to show the known values, as we saw here, where at the ends or at the pins, if we have a moment that equals to 0, So that's all. Good luck.